On April 13th, 2029, an asteroid named Apophis will pass within 19,300 miles of Earth. NASA has looked at the numbers, run the models, and issued the reassurance. We are safe. And for a while, that was enough. A clean headline, a close call that wasn't. The kind of story that gets filed away under science doing its job. But 19,000 miles is not what it sounds like. The satellites that carry your phone calls, your navigation, your weather data, they orbit at roughly 22,000 miles above the surface. Apophis passes below that. It threads through the shell of our own infrastructure, through the layer of machines we built and placed there, close enough that if you could somehow stand on its surface, you would watch the curvature of the Earth fill a significant portion of the sky above you. That is not a safe distance in the way we usually mean safe. That is the distance between here and the edge of what we have already claimed. And here is the part that does not get into the headline. The models are careful, the orbital data is thorough, but the margin between that flyby and something else entirely is governed by things we do not fully control. A nudge from solar wind, accumulated grain by grain over years, is enough to push a path sideways. A tap from another small object, barely detectable, shifts the trajectory in ways that compound over time. A miscalculation in the data we already have, the kind of thing that has happened before with tracked objects, can rewrite the outcome entirely. The reassurance is real. The math supports it. And the gap between that reassurance and a genuinely different result is, by any measure of cosmic scale, essentially nothing. April 13th. That date sits out there with a quietness that the number alone does not quite capture. Something the size of a large skyscraper, moving at a speed that makes any human engineering look stationary, passing through the corridor where we park our satellites. And we are calling that safe. We are right to call it safe. And that might be the most unsettling part of all of this. If you find yourself drawn to questions like this one, the kind that stay with you after the headline has moved on, like and subscribe, so you don't miss where this goes. Let's begin. What we are actually talking about when we talk about Apophis is this. On June 19th, 2004, a telescope at Kitt Peak Observatory in Arizona caught a faint moving point of light against the background of the sky. It was logged the way thousands of objects are logged every year, catalogued, assigned a number, entered into a database as 2004 MN4. At that moment, it was not a story. It was a dot. And then someone ran the numbers. The object was 1,480 feet long. That measurement gets cited often enough that it starts to feel routine, but it is worth spending a moment making it real. The Empire State Building, measured from its base to the tip of its antenna, stands 1,454 feet tall. Apophis is slightly longer than that, but the Empire State Building is anchored into the bedrock of Manhattan, fixed, stationary, built to absorb its own weight in perfect vertical stillness. What the astronomers at Kitt Peak had found was something roughly that size tumbling end over end through deep space at a speed that no human frame of reference is really built to accommodate. Not standing, not hovering, rotating and pitching in a chaotic spin as it moved, so that any given point on its surface might be facing inward, then outward, then sideways, all within the span of a single hour. The scale of a city landmark, but untethered, hurtling, alive in the way that only physics can make something feel alive. That is the object. Hold that image. The mass behind that image is 67 million tons. There is no single familiar comparison that collapses that number into something the body understands, but you can build toward it. A fully loaded supertanker, one of the largest ships ever constructed by human hands, carrying crude oil across an ocean, weighs roughly 600,000 tons. You would need more than 110 of those ships, fully loaded, stacked, and compressed together to approximate what Apophis carries as simple mass. And that is not a ship. That is the weight behind something moving at 19 miles per second. Every second that passes, Apophis crosses 19 miles of space. A rifle bullet travels at roughly 1 mile per second, which already places it beyond anything the human eye can properly track. Apophis moves at 19 times that speed, Not 19% faster, 19 times faster. If you fired a rifle in the time it takes you to blink, the bullet would have traveled perhaps half a mile. In that same blink, Apophis would have crossed 9.5 miles of space, and it has 67 million tons behind it. This is not a metaphor, this is a measurement. When the orbital calculations came back, the probability of impact on April 13th, 2029 was 2.7%, 1 chance in 37. Those numbers were unlike anything the planetary defense community had ever formally assigned to a tracked object. To put that in a frame, the nervous system actually responds to, if you were told before boarding a commercial flight that there was a 1 in 37 probability the aircraft would not land safely, you would not board. No reasonable person would board. You might board a plane with a 1 in 10 million chance of catastrophe, because that probability exists somewhere below conscious concern. 1 in 37 is not below conscious concern. 1 in 37 is the kind of odds that walk into a room and change the temperature. Apophis was assigned a Torino scale rating of 4. The Torino scale is the system astronomers use to communicate impact risk to the public. It runs from 0, which means no concern, to 10, which means a certain collision capable of global destruction. A rating of 4 means a close encounter with a 1% or greater probability of impact, capable of regional devastation. No object in the history of tracked near-Earth asteroids had ever reached a Torino 4, not once. Every other object ever discovered had been resolved downward to 0 before it climbed that high. Apophis climbed there and stayed for a period of weeks that were not comfortable weeks for the people running those calculations. There is a category that planetary scientists use when discussing objects in this size range. They call it a city killer. Not a phrase invented for the press, not a rhetorical flourish, but a classification. An object large enough, dense enough, fast enough to obliterate a metropolitan area upon impact. Not damage it, obliterate it. 67 million tons of rock moving at 19 miles per second, arriving with the kinetic energy of thousands of nuclear warheads delivered at a single point. The phrase city killer is, if anything, understatement. It is the scientist's way of keeping the language controlled while describing something that resists control. They named it Apophis. The original catalog number 2004 MN4 was replaced with a name taken from Egyptian mythology, Apophis, the god of chaos and destruction, the eternal serpent that ancient Egyptians believed swam through the darkness trying to swallow the sun. It is the kind of name that a scientist gives something when the numbers have made them philosophical. And in the months after discovery, the numbers earned the name. Then the telescopes kept watching, and the calculations were refined, and the probability shifted. The impact prediction for the 2029 came down significantly. The official announcement was relief. The close approach would be exactly that. A close approach, not a collision. And for most people, that was the end of the story. But the recalculation that brought relief also found something else. Something smaller, more precise, and in some ways considerably harder to dismiss than a 2.7% probability had ever been. Something smaller, more precise, and considerably harder to dismiss. That phrase needs unpacking, because it sounds like a hedge, like the kind of language scientists use when they want to soften bad news without quite saying it. It is not a hedge. It is a description of a specific physical mechanism with a specific name. And once you understand what it means, the relief of the 2029 miss begins to feel less like relief and more like a postponement. When the recalculation confirmed that Apophis would not strike Earth on April 13th, 2029, the telescopes did not stop. The calculations did not stop. Because passing close to a planet is not a neutral event for an asteroid, it is an interaction, a gravitational exchange, and the path Apophis takes through that exchange determines where it goes next. The researchers tracking that future path found a region, a corridor in space, defined by the precise geometry of Earth's gravity well, through which Apophis would need to pass in 2029 in order for gravity to bend its orbit in a very specific direction. If Apophis threads that corridor, if its trajectory carries it through that particular pocket of space during the close approach, the gravitational influence of Earth reshapes its orbit in exactly the right way to bring it back. Not approximately back, not in the general vicinity, back to the same point in space that Earth will occupy on April 13th, 2036. That corridor has a name. It is called a gravitational keyhole. The keyhole for the 2036 return is roughly 2,000 feet wide. Sit with that for a moment. In the entire vastness of space, a window roughly the length of 6 football fields will determine whether 67 million tons of rock comes back to hit us 7 years later. 2,000 feet is nothing at cosmic scales. It is the distance you might walk on a lunch break, the length of a modest airport runway, a gap you could drive across in under a minute at highway speed. And yet, this 2,000-foot window is sitting somewhere in the orbital geometry of the 2029 approach. And if Apophis passes through it, not anywhere near it, not roughly in its direction, but through it precisely within that specific band, the probability of impact on Easter Sunday, April 13th, 2036, does not increase slightly. It does not climb back toward the numbers that frightened everyone in 2004. It becomes 100%. A near miss becomes a guaranteed return. The window is 2,000 feet wide, and the object trying not to thread it is moving at 19 miles per second. That is not an abstract possibility existing somewhere at the theoretical edge of orbital mechanics. That is the structure of the problem the planetary scientists were actually looking at after the relief wore off. And the reason it cannot be dismissed is what happens when you look more closely at what Apophis actually is, and how it actually moves through space. The early models assumed, reasonably enough, that Apophis was a solid body rotating in a predictable way, the kind of object whose orbit responds to known forces in calculable proportions. The radar data from the Goldstone Solar System radar in California and from the Arecibo Observatory in Puerto Rico painted a more complicated picture. Apophis is not a solid rock. It is what planetary scientists call a rubble pile, not a single fused object but a loose collection of boulders, gravel, and dust held together by nothing more than their mutual gravitational attraction. There is no rigid internal structure, there is no solid core. It is, in the most precise physical sense, a gravitational agreement among fragments that have not yet decided to go their separate ways. Apophis is shaped roughly like a skyscraper laid on its side, and because of that elongated, irregular shape, and because of its unconsolidated interior, it does not rotate cleanly around a stable axis. It tumbles, not the way a coin tumbles end over end in a predictable arc, but chaotically, in a wobbling, irregular spin that makes its orientation at any given moment genuinely difficult to predict with precision. That tumbling matters enormously for what comes next. There is a force acting on Apophis that most people have never heard of, and it is doing something that should not be possible given its size. When sunlight strikes the surface of an asteroid, the rock absorbs that energy and re-radiates it as heat. The heat does not radiate equally in all directions. It escapes slightly more in some directions than others, depending on the asteroid's shape, rotation, and surface composition. That asymmetric heat emission creates an asymmetric thrust, a real force acting continuously in a direction determined by how the asteroid happens to be tumbling at that moment. This is called the Yarkovsky effect, and the force it exerts on Apophis is equal to roughly the weight of an apple sitting on a kitchen table. The weight of an apple, against 67 million tons. The ratio is so extreme that the intuition wants to dismiss it as irrelevant, the way you might dismiss the weight of a single ant on the hood of a freight train. But the freight train analogy breaks down in a critical way, because a freight train moves on fixed rails, and an apple has no capacity to change where those rails lead. Apophis, moving through open space, is different. A force that's small, acting without pause, accumulates. Over months, it drifts the trajectory by feet. Over years, it drifts the trajectory by hundreds of feet. The current best estimate is that the Yarkovsky effect is pushing Apophis approximately 650 feet per year closer to threading the keyhole. 650 feet sounds like nothing. It is nothing, on most scales. But the keyhole is 2,000 feet wide, and the asteroid has been drifting for years and will continue drifting until the 2029 approach, and the exact direction and magnitude of that drift depends on how Apophis is tumbling, which changes unpredictably as the rubble pile shifts its mass distribution in ways the models can only approximate. This is where the prediction problem actually lives. Not in whether we know the laws of physics, we do. Not in whether the telescopes were good enough. At certain moments, they were extraordinary. The problem is that Apophis is not the kind of object those physical laws can be applied to cleanly, because its internal structure introduces variables that compound over time, and because a force the weight of an apple applied to a tumbling rubble pile, in a direction that shifts with the tumble, is exactly the kind of force that a calculation can get slightly wrong early and find deeply wrong by the time it matters. And right now, none of those calculations can be updated. Apophis is currently in the sun's glare, geometrically positioned so that every telescope on Earth is pointed too close to the sun to see it clearly. It will remain effectively invisible until 2027. 2 years of darkness, during which the Yarkovsky drift continues, the tumble continues, and the keyhole waits at its fixed position in the geometry of the 2029 approach, 2,000 feet wide, sitting in the path of something we cannot currently watch. The 2 years of blindness are not a temporary inconvenience. They are a demonstration of something structural about the way we watch the sky, something that applies not just to Apophis in this particular season, but to every object that approaches Earth from a certain direction, at certain times, in certain geometries. The sun sits at the center of the solar system, and every telescope we have built is pointed outward from that center. Looking inward, toward the sun, is not simply difficult. For most purposes, given the instruments and orbital mechanics involved, it is impossible. The glare overwhelms everything. An asteroid approaching from the sunward side is an asteroid that arrives invisible, unannounced, with no warning time at all. For Apophis right now, that means 2 years during which the Yarkovsky drift accumulates without correction, the tumble continues without observation, and any small gravitational nudge from a passing object or a shifting mass distribution inside the rubble pile would alter the trajectory in ways we would not detect until 2027. By then, whatever has changed will already have changed, and the window for doing anything about it shrinks accordingly. But the structural problem extends far beyond those 2 years, and far beyond Apophis. The sunward blind spot is not something that improves with better telescopes, or more funding or sharper optics. It is a geometric fact about where things can approach from, and where we are able to look. Any object that spends a significant portion of its approach trajectory between Earth and the sun is, for most practical purposes, invisible to us until it is very close. And July of 2019 is when that abstract geometric fact stopped being abstract. On the 25th of July 2019, an asteroid designated 2019 OK passed Earth at a distance of roughly 40,000 miles. 40,000 miles sounds like a long way. You would need to drive at highway speed for approximately 60 years without stopping to cover that ground. But the context is what matters here, because 40,000 miles in this domain is not a comfortable margin. Apophis, the asteroid that generated decades of tracking programs and scientific conferences and international concern, will pass at 19,300 miles in 2029. 2019 OK passed at roughly twice that distance. These are objects moving in the same neighborhood of space, measured against the same scale. And the difference in how much warning we had for each of them is the part that stops the breath. Apophis we have known about since June of 2004, more than 2 decades of observation, calculation, radar ping, and telescope time. 2019 OK was detected less than 24 hours before its closest approach. Not weeks, not days, hours. The asteroid was discovered, named, and flew past the planet in a span of time that for most people would constitute a single ordinary workday. You woke up that morning and 2019 OK had not yet been formally identified as a threat. You went to work, You had lunch. You came home. By the time you went to sleep, it was already behind us and receding. That was the entirety of our warning window for an object 400 feet wide. 400 feet is worth dwelling on. It is smaller than Apophis, about a quarter of the length, but smaller does not mean survivable. An object 400 feet wide, striking at the velocities these objects carry, would have released approximately 30 megatons of energy at the point of impact. 30 megatons. The weapon dropped on Hiroshima in 1945 released approximately 1/10 of 1 megaton. To reach 30 megatons, you would need to detonate the Hiroshima device 300 times, simultaneously, at the same location. Not 2 devices, which would already be incomprehensible. Not 10, 300, stacked on the same point in space, released in the same fraction of a second. And 2019 OK, which no human being on Earth knew was coming until it was practically past us, carried that energy inside it as a matter of physics. Not as a weapon designed for destruction, but simply as mass times velocity. The arithmetic of an object that size moving at the speeds these objects move. The 40,000-mile miss means it did not hit. That much is clear. But a trajectory is not a fixed property. It is a line through space that depends on every gravitational interaction the object has experienced. Every photon that has pushed it fractionally sideways. Every imprecision in the initial measurement compounding over years of travel. 2019 OK passed at twice the distance Apophis will reach in 2029. The geometry that produced that miss was not designed. It was not the result of any detection, any intervention, or any preparation. It happened the way it happened, and we learned about it with less than a day to spare. And that was just one asteroid. One object from one direction on one morning in July of 2019. Moving through a sky that contains hundreds of thousands of objects we have not catalogued, many of them approaching from exactly the region of the sky we cannot systematically watch. Chelyabinsk, in February of 2013, came from the direction of the sun, a rock roughly 60 feet across that released the energy of 30 Hiroshima bombs when it exploded in the atmosphere over Russia, injuring more than 1,500 people, shattering windows across 6 cities, and arriving completely undetected by every asteroid monitoring system on the planet. Not undetected because the systems failed. Undetected because the object came from the sun's direction, which is a direction we do not watch, and for which we have never built a systematic solution. So the question that seemed to be about Apophis has become something larger. We have been watching one asteroid for 20 years, with the best radar installations in the world, with dedicated orbital mechanics teams, with international coordination, and we still cannot say with certainty whether it will thread a 2,000-foot keyhole in 2029. That is the object we know best. That is our most studied near-Earth threat. And somewhere behind the sun right now, there are objects we have never seen at all. And yet, even saying that, even sitting with the reality of an unseen object carrying the energy of 300 Hiroshima bombs passing within a single day's notice, there is still a tempting thought. The thought that these are exceptions. That the system, on balance, works. That NASA has been cataloguing near-Earth objects for decades, and that the broader picture, whatever its edges, is mostly under control. That thought is worth examining directly, because the numbers behind it do not support it. NASA's own estimates put the total population of what are formally classified as city killers, asteroids large enough to destroy a metropolitan area and everything within hundreds of miles of the impact point, at approximately 25,000 objects crossing Earth's orbit. 25,000. Of those, astronomers have so far identified and tracked roughly 11,500, which means that approximately 13,500 city killers are, at this moment, somewhere in the inner solar system, on orbits we have not measured, with sizes we have not confirmed, and with trajectories we cannot predict. 13,500 objects, each one capable of ending a city the way you would end a sentence. The honest answer is we do not know where they are. We do not know their sizes. We do not know their orbits. They are out there, and we are not watching them, because we cannot. Consider what 13,500 actually represents as a number of threats. Imagine a city with 25,000 bullets fired in random directions through it, and you have only succeeded in tracking 11,500 of them. You know where those particular bullets are, you know their paths, you can model their trajectories. The other 13,500 are still in motion somewhere inside that city, and all you know is that they are there. That is not a security situation. That is not a partial solution. That is a census of what you do not know, expressed as a count of city killers that have never been seen. The classification itself has become something different at this scale. When astronomers first started using the term city killer, it was a way of distinguishing a certain size class of object from the truly civilization-ending threats at the top of the scale. A clarifying category, clinical and precise. But when you multiply it by 13,500, when you apply it to objects currently crossing Earth's orbit that no human being has ever detected, the word city stops feeling like a size limitation and starts feeling like a roster of places, a roster of possible endings. So, what is the solution? The answer that currently exists is called NEO Surveyor, a space-based infrared telescope specifically designed to hunt near-Earth objects, particularly from angles that ground-based telescopes cannot access because of that permanent geometric blind spot toward the sun. NEO Surveyor is scheduled to launch in 2027, the same year that Apophis emerges from the sun's glare and becomes observable again for the first time since 2023. The timing feels significant, but it does not change the arithmetic. Even after it launches, the most optimistic projections suggest it will take between 10 and 20 years for the telescope to catalogue 90% of the remaining city killers. 10 to 20 years. A child born today will sit down at a college graduation ceremony before we have found 9 out of 10 of the objects that could eliminate the city they grew up in. That is not a figure of speech. That is the actual timeline of our best current solution. And while that solution is being built, the threats continue arriving. In late 2024, astronomers identified an object designated 2024 YR4, a relatively small near-Earth asteroid that, within weeks of its discovery, climbed to an impact probability exceeding 3%. 3%. The number that sent the scientific world into its highest recorded state of alarm when Apophis briefly touched 2.7% in December of 2024 had a successor that exceeded it. 2024 YR4 became, at its peak, the most statistically dangerous object in the modern history of planetary defense monitoring. It was later downgraded as additional observations refined the orbital solution. But the fact of its existence, the fact that a 3% threat materialized from the catalogue of unknowns in a single discovery cycle, is not a footnote. It is a demonstration of the problem. Other nations have drawn that conclusion. China has established the first dedicated governmental planetary defense unit of its kind, structured with the formality and urgency of a standing military division. The recruitment criteria are specific. Astrophysicists under the age of 35. Not because older scientists are less capable, but because the institutional logic behind that age limit implies something about the timeline being planned for. You recruit young when you expect the mission to span careers. You recruit young when you are building infrastructure designed to outlast the people who started it. China is building a planetary defense force with the urgency of an institution that believes the problem is generational, not administrative, and that the response must be scaled accordingly. By 2030, they plan to dispatch a dual spacecraft mission to Asteroid 2015 XF261, not as a study mission, not as a flyby, but as a deflection attempt, a live test of the mechanics of planetary defense conducted against a real near-Earth object, with a target date less than a decade from now. And all of this, the NEO Surveyor timeline, the Chinese mobilization, the 3% alarm of 2024 YR4 is happening while roughly 50 objects pass inside the orbital shell of our satellites every single year. 50 times a year, an object threads the space between the Earth and the machines we have placed in orbit around it. And the majority of those passages are detected only in retrospect, if at all. The gap between the threat and the response is not closing. It is being acknowledged by governments and space agencies out of something that looks increasingly like genuine fear. But detection only tells you what is coming. It says nothing about what has already arrived. And buried in the surface of this planet, compressed into layers of sediment and melted rock, is evidence that something vast got through long before anyone was watching, and that the world it found was not empty. The evidence buried in this planet's surface is not theoretical. It does not require modeling or projection or probabilistic math. It requires only a shovel and a willingness to look at what the soil actually contains. Because what it contains, in dozens of locations across the breadth of this world, is the signature of something that arrived from above with enough force to remake everything below. 12,800 years ago, a comet struck the Earth. Not millions of years ago in the time of dinosaurs, not hundreds of thousands of years ago in some epoch so remote, it feels like a different planet entirely. 12,800 years ago. There were people alive when this happened. There were people building shelters and raising children and carrying knowledge forward through story and song. Agriculture had not yet taken hold in most places, but humanity was here, present, distributed across every continent, doing what humans do, persisting, accumulating, making meaning. And in the span of an event that by geological standards would register as barely a tremor in the record, 2 out of every 3 of them disappeared. The object itself was a comet approximately 62 miles wide that had fragmented before its arrival, breaking apart over days or hours into a swarm of impactors that descended not as a single blow, but as something more like a barrage. To feel the scale of 62 miles as a physical dimension rather than an abstraction, consider the distance from where you live to the nearest large city, or the length of a coastline you have driven along, or the stretch of highway between 2 towns you pass through on a long trip. That is a measurement you could walk across in a day if the terrain allowed. Now, hold that distance in your mind and extend it in every direction, length, width, depth, and consider that this is the object that came apart above the North American ice sheet and delivered its fragments across a continent that was, at the time, still buried under glacial ice more than a mile thick in places. What those fragments left behind is called the Younger Dryas boundary layer. Geologists and archaeologists who encounter it in the field sometimes call it the black mat, because that is what it looks like when you expose it in a cross-section of Earth. A dark, compressed horizon of material that sits like a dividing line between 2 different worlds. Below it, there are animal bones and human tools and the ordinary debris of a functioning ecosystem. Above it, in the layer immediately following, those things largely vanish. The black mat is not a metaphor. It is a measurement. And within that layer, at more than 40 sites across 4 continents, researchers have found the same suite of materials, appearing together in concentrations that have no ordinary geological explanation. Iridium, which is extraordinarily rare in the Earth's crust, but common in the bodies that travel through space. Shocked quartz, which can only be formed under pressures so extreme that nothing on the surface of this planet can generate them. Only nuclear detonations and cosmic impacts produce the crystalline fracture patterns that make quartz look the way it does in these samples. Nanodiamonds, which require conditions of heat and pressure so specific and so violent that their presence in a sedimentary layer is essentially a signature. And microscopic spherules of melted rock, tiny glass beads formed when material is heated past melting, and then cooled rapidly as it travels through the air, found in concentrations millions of times higher than anything that ambient geological processes could explain. Millions of times above normal is the kind of number that resists instinct. So consider it this way. If you walked across a desert and found scattered grains of ocean salt in the sand, you would find it unusual. If you found them occasionally, maybe you would attribute it to wind patterns, to distant spray, to something ordinary and diffuse. But if you gathered a handful of that desert sand and found it was composed almost entirely of ocean salt, if the ratio of salt to sand was not 1 part in 1,000 but 1 part in 1, you would not argue about wind patterns anymore. The only explanation that survives scrutiny is that something brought it there in quantity, from somewhere else, all at once, That is what the iridium at the Younger Dryas boundary is. That is what the nanodiamonds are. The concentrations are not anomalous. They are impossible to explain by anything other than what the evidence describes. When the fragments struck the ice sheet, the energy released was sufficient to destabilize ice that had been accumulating for tens of thousands of years. The meltwater poured into the oceans in volumes large enough to raise sea levels measurably, flooding coastlines and erasing the low-lying land bridges and shoreline settlements that human populations had come to occupy. Wildfires spread across continents already stressed by the thermal pulse of the impacts. And then the cold came, because the dust and debris and water vapor thrown into the atmosphere by those impacts altered the circulation of heat across the planet and triggered a freeze that lasted approximately 1,200 years. Not 12 months, not 12 decades, 12 centuries of anomalous cold. From the moment those fragments struck to the moment the climate finally stabilized again is roughly the same span of time as from the fall of the Roman Empire to the present day. Entire civilizations rose and fell and were forgotten in the time it took the Earth to recover from what landed on it that day. The biological accounting is staggering in its specificity. Across North America, 75% of the large animal species that had existed before the Younger Dryas boundary ceased to exist after it. The mammoths went silent. The mastodons, which had ranged across the continent for millions of years, vanished completely from the record within what the geological clock can only describe as an eye blink. The saber-toothed cats, the American horses that had evolved on this continent and spread across it for millions of years before humans ever arrived, all of them gone, their bones appearing in abundance below the black mat and barely at all above it. And alongside them, the first widespread human culture of North America, the people archaeologists call the Clovis, disappeared from the archaeological record so completely and so abruptly that their absence itself became a research problem. Not a gradual fading, but a discontinuity, a line in the soil past which their tools and their camps and their presence simply stop appearing. This is not ancient history. This happened while humans were alive, while they were building, while they were telling stories around fires. 2 out of every 3 people on Earth disappeared. The number sits there and does not shrink no matter how long you look at it. And the object responsible was not an asteroid. It was a comet, which means the rules that governed how Apophis was found, tracked, measured, and refined over 20 years of careful observation. Those rules do not fully apply to what struck 12,800 years ago. Because comets play by different rules entirely, and in almost every dimension that matters for planetary defense, those rules are worse. The difference between an asteroid and a comet is not merely a question of composition, it is a question of category, in almost every dimension that matters for survival. Everything that has been described so far, Apophis, the city killers catalogued and uncatalogued, the Younger Dryas fragments that reset the biological ledger of a continent, all of that belongs to one column. Comets belong to a different column entirely, and when you move from one column to the other, the numbers do not increase gradually. They lurch upward in a way that makes the first column feel, in retrospect, like the manageable version of the problem. Start with speed, because speed is where the gap opens first. Apophis travels at approximately 19 miles per second. That number already sits well outside ordinary intuition, 19 times faster than a rifle bullet, fast enough to cross the continental United States in under 3 minutes. But a comet arriving from the outer solar system travels at roughly 45 miles per second. That is not twice as fast, though it would be alarming enough if it were. It is more than twice as fast, 2 1/3 times as fast. And the reason that distinction matters so much is that destructive energy does not scale with speed linearly. It scales with the square of speed. If you double the velocity, you quadruple the energy. If you multiply the velocity by 2 1/3, you multiply the energy by more than 5. But the actual ratio between 19 miles per second and 45 miles per second, squared, means that a comet of exactly the same size and mass as a given asteroid delivers more than 9 times the destructive energy on impact. Not 9 times worse in some abstract sense. 9 times the force, the heat, The pressure wave, the ejector thrown into the atmosphere. Everything the physics produces is 9 times more of it, because the object was moving more than twice as fast when it arrived. And comets arrive with almost no warning. Asteroids like Apophis inhabit the inner solar system. They orbit the sun on paths that bring them through the neighborhood of Earth repeatedly, which is precisely what allowed 2 astronomers at Kitt Peak to spot it in June of 2004 and begin the years of measurement that refined its trajectory. The warning time for Apophis was approximately 25 years. That is long enough, in principle, for civilization to respond. Comets come from somewhere else entirely. From the outer reaches of the solar system, from the Oort cloud and the Kuiper belt, following long elliptical orbits that carry them billions of miles from the sun for most of their existence, before swinging inward on a trajectory that may bring them close to Earth. They spend most of their lives in darkness far beyond the range of current telescopes. And because their orbits are so elongated, they arrive fast and they arrive suddenly. The honest estimate for warning time on an incoming long-period comet is as little as 6 months. Not 6 years, not 6 decades. 6 months from the moment of detection to the moment of arrival, if detection happens at all, and detection is far from guaranteed for an object that has spent 10,000 years in the dark and is arriving from a direction the sun's glare may well be obscuring. So when you take an object that is 9 times more destructive per unit of mass, arriving at more than twice the speed, with a fraction of the warning time, you are no longer talking about the same problem with a higher difficulty setting. You are talking about a problem that the entire infrastructure built around Apophis, around radar measurement and Yarkovsky drift, and gravitational keyholes, is simply not designed to solve. And then there is Swift-Tuttle. Comet Swift-Tuttle was discovered independently by 2 astronomers in 1862, and it completes 1 orbit around the sun approximately every 130 years. It is 16 miles wide. To make that number mean something, consider what happened 66 million years ago when the object that killed the non-avian dinosaurs struck the coast of what is now Mexico, the Chicxulub impactor, which has become the reference point for extinction-level catastrophe, the most famous act of cosmic destruction in Earth's recent history. That object was somewhere between 6 and 9 miles wide. Swift-Tuttle is 16 miles wide, but the width alone does not capture it, because Swift-Tuttle would not arrive at asteroid speeds. It would arrive at comet speeds. When you account for both the mass and the velocity together, Swift-Tuttle striking Earth would release approximately 27 times more energy than the Chicxulub impact. The event that ended the age of the dinosaurs, that ended 165 million years of dinosaur dominance, that threw so much debris into the atmosphere that the sky darkened for years and the global food chain collapsed. That event would be a rounding error compared to what Swift-Tuttle would deliver. One astronomer working through the orbital calculations described it plainly as the single most dangerous object known to humanity. That is not hyperbole. That is the number 27, applied to the worst thing that has ever happened to life on this planet. And here's the thing about Swift-Tuttle that changes the texture of the night sky if you let yourself think about it for long enough. Every August, people lie on blankets in fields and parking lots and rooftops and watch the Perseid meteor shower. Dozens of streaks of light per hour, reliable and beautiful, and one of the more accessible spectacles the sky offers. The Perseids are debris from Swift-Tuttle, trillions of fragments, ranging from grains of dust to objects considerably larger, strewn along the orbital path of the most dangerous object known to humanity, and every year, Earth passes directly through that debris trail. The streaks of light are pieces of it burning up in the atmosphere. The show is real. The origin is real. Something that millions of people point their children toward on warm August nights is the shattered remains of the object that, if it arrived intact, would make every extinction event in the last 100 million years look like a prelude. The Perseids are one meteor shower, one debris field from one object. But the sky is full of these trails, and Earth does not pass through just one of them each year. It passes through 12 or 13. 12 or 13 times every year, the planet crosses the orbital path of a comet, and moves through whatever that comet left behind. The Leonids in November, which in peak years can produce hundreds of thousands of meteors per hour. That stream comes from a comet 2.5 miles wide, and in extraordinary years, it does not look like a shower at all, but like a continuous rain of light, as though the atmosphere itself is on fire. Every one of those streaks is a fragment burning up. Every one of those fragments came from something. And the more you look at the list, the more the night sky starts to feel less like a backdrop, and more like a map of everything that has ever come apart up there and left pieces behind on the path Earth keeps traveling. But of all the debris fields the planet crosses each year, the one that changes the arithmetic most completely is the Taurid meteor stream. The Taurids are not the most dramatic shower. They are slow, and they produce relatively few meteors per hour on a typical night. And most people watching them would describe the experience as quiet and sparse compared to the Leonids or the Perseids. But the Taurid stream itself is 20 million miles wide. That number requires a moment. The planet you're sitting on right now is roughly 8,000 miles across, which means the Taurid stream is approximately 2,500 Earths, laid side by side. If you lined up every planet in the solar system in a row, you would not come close to matching the width of this debris field. Earth enters it twice every year, once in late October and once in late June, and the crossing lasts for weeks each time. During those weeks, the planet is moving through a structure so vast that describing it as a debris field almost understates it. It is more like a river of material wide enough to swallow the distance between here and the sun twice over. And we pass through the middle of it on a fixed schedule, every year, without exception. And the Taurid stream does not contain only dust. It contains objects ranging from grains of sand to fragments the size of cities. That phrase, city-sized, has appeared in this conversation before, attached to asteroids in the catalogue, tracked objects with names and orbital histories, and probability tables. Here it applies to objects that are not in any catalogue at all, embedded in a debris field so vast and so diffuse that surveying its full contents is, at this point, genuinely beyond what has been accomplished. When astronomers are asked how many large objects, truly large objects, are currently in the Taurid stream, the honest answer is that nobody knows. It could be 10. It could be 100. That is not a paraphrase of scientific uncertainty. That is the actual range being discussed. An order of magnitude spread. Between 10 and 100 objects that could each qualify as a city killer, embedded in a debris field Earth crosses twice a year, and the number has not been resolved. The city killer designation has been applied throughout this conversation to tracked asteroids, objects we have measured and catalogued and assigned probabilities to. Here it describes something else, a population of objects whose size we have bounded, but whose count remains an open question, moving through a structure so large that finding all of them would require capabilities that do not yet exist. Now, consider what falls out of that stream during the crossing. In 1908, something entered the atmosphere over a remote region of Siberia called Tunguska, and it exploded before it reached the ground. The object was approximately 200 feet wide, roughly the size of a large building, not enormous by the standards being discussed here, not a city killer by most definitions, certainly nothing approaching Apophis or Swift-Tuttle, and it flattened 80 million trees. If you tried to picture 80 million trees, one useful frame is this. That number of mature trees would cover an area comparable to a small country. Continuous dense forest from one horizon to another in every direction. And it was all knocked flat in seconds by the pressure wave of an object that did not even make contact with the ground. The fragment disintegrated in the air above it. The destruction arrived as a shockwave, moving outward from the point of detonation faster than anything on the surface could react to. If that object had arrived 4 hours and 47 minutes later, which is the amount of time needed for Earth's rotation to bring a major urban center into alignment with the trajectory, it would not have flattened a forest. It would have ended a city, not damaged it, not set it back decades, ended it, the way a sentence is ended, completely and without remainder. London, Paris, New York, any of them would be gone. The Tunguska event happened during the Taurid meteor shower peak. The fragment was almost certainly part of that stream. So when someone asks how often things like this happen, the answer requires a small kind of reorientation. Your first instinct, shaped by everything you have learned about extinction events being separated by tens of millions of years, might be to guess every 100 million years, every 10 million, every million. The honest statistical average, accounting for cometary fragments of all sizes, is once every 3 days. Not once every 3 million years, not once every 3,000. Once every 3 days, somewhere on Earth, something from the debris fields filling the inner solar system completes its fall and arrives. Most of them are small enough that the ocean absorbs them without a trace, or they burn up cleanly in the atmosphere, or they land in one of the vast uninhabited stretches of land the planet still has. Tunguska was Siberia. The next one might be too, but the frequency is not a geological rarity. It is closer to a weather pattern, and embedded in that pattern, crossing through the 20 million mile wide Taurid stream twice every year, Earth is passing through a structure that contains objects we cannot count and cannot currently see from the direction the sun's glare is always obscuring. The next time someone points at a shooting star and makes a wish, what they are watching is a piece of something that could end a city burning up in the atmosphere above them. The light is real. The beauty is real. The origin is also real. And right now, there are approximately 50 objects each year that pass closer to Earth than the satellites carrying our telephone calls and weather forecasts and GPS coordinates. 50 objects threading through the shell of infrastructure the modern world depends on. Most of them going unannounced. Some detected only after they have already passed. The question that follows from all of this is not whether the threat exists. It is what, exactly, we could do about it if we saw something coming in time to act. And what we could do almost certainly depends on how much time we have. And there was a moment on the 26th of September, 2022, when the answer to that question looked like it might be genuinely good news. NASA's double asteroid redirection test, DART, had been traveling through space for 10 months by then, and at roughly 7 in the evening Eastern Time, a spacecraft weighing 1,200 pounds closed the final distance between itself and a small asteroid called Dimorphos and struck it at 14,000 miles per hour. 1,200 pounds sounds modest. It is roughly the weight of a small car, the kind of vehicle you might see parallel parked outside an apartment building. Unremarkable, compact, ordinary. And Dimorphos is roughly 500 feet across, which means that what humanity did on that evening was aim the rough equivalent of a subcompact automobile at a rock the size of a sports stadium and ask whether the collision would matter. The speed involved makes that comparison feel less absurd once you sit with it. A rifle bullet travels at roughly 2,000 miles per hour, which means DART struck Dimorphos at 7 times the speed of a bullet, carrying all the kinetic energy of a weapon system compressed into the frame of something that would not look out of place in a parking lot. The impact was not an explosion. It was physics made deliberate. One object transferring a momentum to another, exactly as the engineers intended. And it worked. The orbital period of Dimorphos, the time it takes to complete one loop around its parent asteroid, Didymos, shortened by 33 minutes. The mission required a change of 73 seconds to be considered a success. What they got was 33 minutes, which is 25 times more than the minimum threshold. The first time in recorded history that a human civilization intentionally changed the trajectory of a celestial body, it did not merely succeed. It exceeded every expectation by a factor of 25. That should feel like a triumph. And for a moment, let it. Sit with what that actually means. A species that arrived on this planet 400,000 years ago, that spent most of that time unable to read or write or build a structure that would last a winter, reached out across the solar system with a machine it designed and built and aimed and sent on a 10-month journey, and changed the path of a rock orbiting another rock millions of miles from home. That is not a small thing. It is one of the largest things our civilization has ever done, and it happened in our lifetime. But then, the detail that produced the success demands a closer look. because it is the same detail that makes the outcome terrifying if you're trying to build a reliable defense system around it. Dimorphos, like Apophis, is a rubble pile, not a solid rock, but a gravitationally bound collection of loosely packed debris, held together less by its own structural integrity than by the gentle mutual attraction of its own pieces. When DART struck, the collision did not simply transfer momentum from spacecraft to asteroid, the way a cue ball transfers momentum to a billiard ball, cleanly and predictably. The impact excavated a massive plume of debris, dust, gravel, fragments of dislodged surface material, and that plume expanded outward into space and acted like a thruster. The escaping material pushed back against Dimorphos the way exhaust pushes back against a rocket engine, and that secondary thrust was responsible for most of the deflection, not the collision itself. The rubble pile, by absorbing and then ejecting material, amplified the effect far beyond what the impact alone could have produced. That amplification is why the mission worked as well as it did. And that amplification is precisely the problem. If DART's effect was 25 times greater than the minimum required outcome, what that means, stated plainly, is that the actual models predicted the deflection would be roughly 1/25th as large as what occurred. The engineers had ranges, uncertainties, error bars, but the real-world result exceeded the predicted result by a factor of 25, and in the specific domain of planetary defense, being off by a factor of 25 is not a rounding error. If you're trying to push an asteroid that would otherwise thread a 2,000-foot gravitational keyhole, the difference between nudging it exactly the right amount and nudging it 25 times too hard is the difference between a clean miss and a new trajectory that could still intersect with Earth on a later pass. Rubble piles do not behave predictably under impact. The internal structure varies, the angle of impact matters, the rotational state of the object matters, the composition of the surface layer matters, and all of those variables interact in ways that current models cannot fully resolve. The irony is almost cruel. The same loose, fragile architecture that makes these objects easier to deflect is precisely what makes the outcome of any deflection attempt impossible to guarantee. We can hit the target. We cannot reliably know what will happen after we do. And all of this assumes something that cannot be taken for granted. That we have years to plan, design, build, launch, and observe the effects before any correction needs to be applied. Real deflection, the kind that works, requires lead time measured not in months, but in years, preferably decades. The farther out from Earth a deflection is applied, the smaller the nudge needs to be to produce a clean miss. A push applied 10 years before impact needs only a fraction of the force required, by a push applied 5 years out, which needs only a fraction of what would be required with 2 years remaining. The geometry of the problem rewards early action so severely that late action becomes nearly useless. But sometimes the warning is not years. Sometimes, as 2019 OK demonstrated, it is hours. And for a threat arriving with hours of warning, or days or weeks, there is only one option that could conceivably work: a nuclear detonation near or against the object, coupling enough energy to vaporize or redirect it in a single engagement. The physics of that option are real. The engineering is not beyond reach. The legal framework, however, is explicit. The Outer Space Treaty of 1967, signed by over 100 nations including the United States, Russia, and China, prohibits the placement of nuclear weapons in space. A nuclear planetary defense mission would require either an exception, a withdrawal, or a violation. And the treaty was not written with exceptions for scenarios like this, because in 1967, the scenario was not the part of the problem anyone was focused on. The document that governs human behavior in space was written during the Cold War, with the primary concern being that one superpower might station warheads in orbit to threaten another. The notion that those same warheads might one day be the only tool capable of protecting everyone on Earth from an object arriving without warning was not the architecture the treaty was designed to address. So what we have, as things stand, is this: a deflection method that works but is unpredictable, requires years of lead time, and has been tested exactly once, and a short notice alternative that is physically viable, legally prohibited, and politically untouched by any serious international framework for resolving that contradiction. The technology is real. The talent that built DART is real. The money required to do more is not beyond the reach of the civilizations involved. The one resource that cannot be manufactured on demand, the one variable that the entire enterprise of planetary defense depends on more than any other, it was time. And the objects that most concern us, the ones we cannot yet see, arriving from directions the sun perpetually obscures, catalogued only in the fraction that we have managed to find so far, do not negotiate on timelines. They arrive when the mathematics of the solar system delivers them, indifferent to whether we were ready. So let's ask the question that the defense gap makes unavoidable. What does failure actually look like? Not as a statistic, not as a probability distribution, not as a line on a Torino scale. What does it look like as a human experience, lived by specific people, in specific places, on specific days? Imagine that the keyhole is threaded. The year is somewhere ahead of us, and the instruments confirm what the models had feared. A deviation of 0.003 degrees in Apophis's orbital path, small enough that it would have been invisible without the decades of tracking that preceded it. Small enough that most people, hearing the number, would not initially understand what it meant. But the astronomers understand. The telescopes confirm it on multiple nights. The calculations are run, and run again, and run a third time by a separate team with no knowledge of the previous results. And every time, the answer is the same. April 13th is no longer a close approach. April 13th is a date that has acquired a completely different meaning. And the people who understand orbital mechanics sit with that meaning for a moment before anyone is told. The 90-day countdown begins not with a press conference, but with a phone call at 3 a.m. to a senior official who is not yet awake. By the time the announcement comes, gas in Los Angeles is already at $47 per gallon. Not because the supply chain has failed, the tankers are still moving, the refineries are still running, but because everyone who owns a car and has heard the news is filling it all at once, and the stations that are still open are charging what the market will bear. The economy does not collapse in a declaration. It collapses at the pump, in a line of cars stretching 4 blocks from a Shell station in Culver City, where a man near the back of the line is doing arithmetic on his phone, calculating whether the gas he can afford will take him far enough to matter. 3 million people leave Los Angeles in the 14 days following the announcement. That number is not a measure of panic. It is a measure of those who could go. They had cars that ran, credit cards that worked, family somewhere else with a spare room, a reason to believe that somewhere else would be meaningfully different from here. The wealthy leave first. Beverly Hills empties in a way that reveals exactly how much preparation the wealthy had always been doing quietly. The go bags, and the second homes, and the private airstrips that no one talked about, but everyone suspected. The houses on Sunset Boulevard go dark one by one. The gardens, maintained for decades by workers who cannot afford to leave, are left running on automatic sprinkler timers for a week before anyone thinks to turn them off. The last commercial passenger flight to depart LAX is a United Airlines service to Denver. It takes off at 2:17 in the afternoon on a Tuesday, and it is not full, because by that point most of the people who were going to leave by air have already left, and the ones remaining have reasons that no aircraft can solve. The pilots know this is the last flight. They do not announce it over the intercom. The LAPD does not dissolve in a single day. It dissolves the way most institutions dissolve under terminal pressure. Gradually, then completely. Officers stop showing up for shifts, not because they are cowards, but because they are also fathers and mothers, and sons and daughters with people of their own who need them somewhere else. By the end of the 3rd week, the Crips and the Sureños, organizations that have spent decades in active conflict with each other, are coordinating food distribution in neighborhoods that the city no longer has the personnel to reach. Whether to call that law enforcement is a question that no longer has a meaningful answer. In the schools that are still open, and some of them are because the teachers who show up are the ones who understand that children need somewhere to be, the curriculum has become something no curriculum committee ever designed. Teachers, with no guidance from anyone above them, begin running drills that are not tornado drills and not fire drills, but something closer to what one teacher in East Hollywood calls a goodbye drill. Children sit in circles and practice saying the words, "I love you. I am not going to make it. You need to know how much you matter to me." The teacher does not tell the children these are the right words. She tells them these are words worth knowing how to say out loud. And the children, because children understand more than adults assume they do, say them carefully, as if practicing a language they hope never to need. A vial of insulin in the 4th week costs 3 gallons of water. This is not a policy. It is the arithmetic of 2 people who each have something the other person needs more than anything else, and no institutional structure left to mediate the transaction. The diabetics are not the first people to die, but they are among the first to understand that the ordinary machinery of staying alive, the pharmacies, the insurance networks, the cold chain that keeps medication viable, has stopped functioning in any meaningful way, and that what replaces it is whatever you happen to have, traded to whoever happens to want it. In Brentwood, an elderly couple who have been married for 50 years sit on the front porch of the house where they raised their children. They have been asked, more than once, to leave with various groups heading east. They have declined, politely, each time. They are holding hands in the way people hold hands when they have been doing it for so long that it has become the default position of 2 bodies that have learned to exist near each other. They are not afraid in the way the news describes fear. They are something else, present and deliberate and together, in the house they chose, on a street that has otherwise gone quiet. They are not leaving. April 13th is coming, and the Pacific Ocean, in the hours before it arrives, does something that no one who sees it will be able to explain to someone who did not. The water pulls back, more than 20 feet, retreating from the shore in a long, slow withdrawal, as if the ocean itself is drawing a breath before something that even the sea cannot remain still for. The tide gauges register it. The seismographs in the basement of Caltech detect a microquake every 90 seconds, each one small, each one steady, the earth flinching in regular intervals at something approaching through the dark. The birds have been gone for 2 days. The dogs left the beaches the day before that. Every animal on the coast except the humans has understood something, at a register below language, and moved accordingly. The sky to the west is clear, and the sun is still hours from the horizon. And then it appears, not as a streak across the sky, which is what most people expect, because a streak implies movement across a field of view, something traveling from one side of your vision to the other. Apophis does not do that. It comes directly toward the coast, which means it grows. That is all it does at first. It simply grows a point of light that was not there the night before, becoming visible in the early morning sky, and then becoming undeniable, filling more of the sky with each passing hour than any object that is not the sun or the moon has any business filling. Astronomers describe angular size in degrees. The full moon occupies about half a degree of sky when you look up at it. Hold 2 fingers together at arm's length. That gap, that small space between them, is roughly 2 degrees. Apophis, in the final minutes before it reaches the coast, fills 3 degrees of sky, and it is tumbling end over end, and you can see that it is tumbling, which means you can see the shape of it rotating against the sky, a dark, irregular mass that catches the morning light unevenly as it spins, and it is getting larger with every second that you watch it. The last thing most people who are outside see is not a fireball. This is important. The flash arrives first, and the flash is not bright in the way that sunlight is bright, or the way a camera flash is bright. The word people reach for afterward, the people who are far enough away to survive the initial moment, is white. Not orange, not yellow, white. A total erasure of visual information, as if someone had simply replaced the world with a single uniform color that contains nothing, no depth, no shape, no shadow, and then the world came back, changed in ways that took time to understand. Catalina Island is 22 miles off the coast of Los Angeles. On an ordinary morning, you can see it from the shore on clear days, a low shape on the horizon, something permanent and indifferent to anything happening on shore. Catalina does not survive April 13th. This is not a sentence that means Catalina is damaged, or flooded, or depopulated. It means that the rock and soil and vegetation and the 8,000 or so people who chose to stay are subjected to a pressure and a temperature that the material world cannot withstand, and that Catalina is returned to its constituent elements. It is atomized, which is a clinical word for a thing that has no clinical quality to it at all. The thermal pulse travels outward from the impact site at the speed of light, which means that everyone within 100 miles receives it before they hear anything, before the ground moves beneath them. Before the blast wave arrives, everything within that radius, buildings, vegetation, vehicles, the contents of parking lots and front porches and hospital waiting rooms, reaches ignition temperature simultaneously, not sequentially, not a fire that starts in one place and spreads. Every combustible surface within a circle stretching from Santa Barbara to San Diego, from the coast to well past the mountains, begins burning at the same moment. The sky does not darken from smoke. The sky turns orange from below, the way it looks during the worst wildfire seasons except from every direction at once. A horizon that has become a ring of fire encircling the basin. Then, the blast wave. It travels outward at Mach 2, which is roughly 800 miles per hour. And what that means for a building, for any structure that was designed to resist forces measured in pounds per square foot, is that the atmosphere itself has become a physical object moving through the landscape with a force that treats engineered resistance as if it does not exist. The distance from Los Angeles to San Diego is about 120 miles. The distance to Bakersfield is about 100 miles in the other direction. The wave does not discriminate by construction type or building code or historical significance. It passes through everything. The fireball climbs 60 miles into the atmosphere, which means it has pierced the mesosphere, the layer of the atmosphere where meteors typically burn, the layer that is by definition outside the domain of ordinary weather, and it is carrying material at a temperature that exceeds 10,000 degrees Celsius. The surface of the sun, the actual surface of a star, sits at roughly 5,500 degrees. The plume rising from the Pacific is nearly twice as hot. What that means, in practical terms, is that the rock and water and ocean floor material carried upward into that column is not melting. It is not burning. It is becoming gas. The Earth itself, the literal material of the planet, is transitioning from solid and liquid into vapor, and that vapor is being ejected into the upper atmosphere, where it will circle the globe and cool and fall back down as glass. The earthquake that the impact generates registers 10.5 on the Richter scale. The strongest earthquake ever recorded by instruments on this planet was the 1960 Valdivia earthquake in Chile, which reached 9.5, a number that collapsed buildings across South America and sent tsunamis across the entire Pacific. The Richter scale is logarithmic, which means each full point represents roughly 30 times more energy released. The difference between 9.5 and 10.5 is not one unit. It is approximately 30 times more energy than the largest earthquake in recorded human history, arriving not from a fault line deep in the crust, but from a point source at the surface of the Pacific Ocean, propagating outward through the bedrock of the continent in every direction at once. In the sea floor, where Apophis meets the crust of the Pacific plate, there is a hole. It is 12 miles across, which means it is wider than the island of Manhattan is long. A wound in the ocean floor that reaches into layers of the Earth that have not been exposed to seawater in geological time. The ocean rushes into it, and then the ocean rushes away from it. And what that means for anyone standing on a coast within several thousand miles is that the water around them is behaving in a way that no living human has any instinctive framework for understanding. The Pacific had already pulled back more than 20 feet before the impact, in those final hours, like it was holding its breath. After the impact, what returns is not the Pacific. What returns is a wall of water 150 meters tall, moving at 450 miles per hour. If you wanted to describe this physically, if you wanted to give it a shape the mind can hold, imagine a skyscraper made of water. The full height of a skyscraper, not the top floors, but the entire structure from foundation to roof, moving faster than a commercial jet, with no intention of slowing, and nowhere to go but through everything in its path. Sit with that image for a moment. A wall of water taller than a skyscraper, moving faster than a commercial jet, with nowhere to go but through everything in its path. In the last 8 minutes before the impact, across Los Angeles County, 847,000 text messages were sent containing the words, "I love you." This is a number that the cell networks recorded, because the cell networks were still functioning in those final minutes, still routing traffic, still doing the ordinary mechanical work of connecting one phone to another. Most of those messages were never delivered. The towers that would have completed the connection were inside the thermal radius, or were destroyed by the wave, or simply stopped receiving power at the moment they would have needed it most. 847,000 times, someone in Los Angeles County found the words they had been meaning to say and sent them out into a network that could not carry them all the way home. That is not a detail about infrastructure failure. That is the sound the world makes when it understands what it is losing. Ejecta from the impact reaches 7 states. Not debris, not ash, actual material from the impact site, traveling on ballistic trajectories through the upper atmosphere before returning to Earth at temperatures that set secondary fires across the southwest. What does not burn is buried. What is not buried is submerged. The wave does not stop at the shoreline. It does not stop at the freeway. It does not stop at the mountains. 4 billion people, 80% of animal species. These are the numbers that survive the mathematics of what April 13th does to the planet. And they are the numbers that carry us toward what comes next. Because there are people who do not die on this day, and some of them are underground, and they have enough food and water and air for a period of time that they calculated carefully and hoped they had calculated correctly, and what they are waiting for. In the dark and the silence below a continent that has just been remade is the question of whether anything above them is still there. And that question, whether anything above them is still there, is the question that defines the first year. Not the grief, though there is grief. Not the fear, though there is that too. In abundance, in every tunnel and every shaft and every sealed corridor where people are learning, for the first time in the history of the species, what it means to live entirely without sky. The question that organizes everything, that gives shape to the days when days stop having any meaning on their own, is the practical, unglamorous, relentless question of survival. Because 4 billion people did not die on April 13th. And the ones who did not die needed to eat. 2 million people sheltered in the Moscow metro. You have to hold that number for a moment before you let it pass, because 2 million is not an abstraction you can picture the way you picture a single person. 2 million people is a city. It is a major city placed underground, in a tunnel system built for transit, now being asked to function as a civilization. Moscow's metro is deep, intentionally, historically deep. Built during the Soviet era to double as a shelter, with stations some of which sit nearly 60 meters below the surface. The escalators descending to those platforms are longer than the height of some buildings. And in the months after the impact, 2 million people were riding those escalators down and not coming back up. Because coming back up meant stepping into an atmosphere still thick with particulate debris, in temperatures that had dropped nearly 10 degrees as the dust blocked a meaningful fraction of the incoming sunlight. The cold came fast, the dark came with it, and 2 million people looked at each other in the electric light of station platforms and began the work of staying alive. London held 500,000. The underground, the tube, as Londoners have called it for over a century, was never designed for this. Moscow's system was built with civil defense in mind, with wide platforms and deep shafts that could absorb the secondary use of human habitation. London's was built for commuters. The platforms are narrow in places. The tunnels have specific curves and gradients that reflect the 19th century engineering of a city that had no idea it was building a future shelter. But 500,000 people found their way down into it, and they stayed, and they organized themselves with the particular stubbornness that characterizes people who have nowhere else to be. The first days were chaotic in the way that any situation becomes chaotic when it outruns the planning that was supposed to contain it. Disease moved through the tunnels the way disease has always moved through places where large numbers of people are confined without adequate sanitation. Cholera, dysentery, diseases that belonged to an earlier century, diseases that the living memory of the developed world had largely filed away as solved problems, returned with the patience of things that have never actually been solved, only managed. The management had required infrastructure, and the infrastructure was either gone or unreachable. People died of things that 6 months earlier, a 48-hour course of antibiotics would have addressed without drama. And the people who survived them were, in some sense, the founders of whatever came next. Because something did come next. And the fact that it came next, the fact that it came in the form of mushrooms and cannabis farm lighting equipment, and ham radio operators in Tulsa asking if anyone in Dallas could still hear them, is one of those things about human beings that resists any simple categorization as either hopeful or terrible. It is simply what happened. The mushrooms came from the intersection of two things: the availability of organic material in quantities that no one wanted to think too carefully about, and the LED lighting rigs that began appearing in underground colonies within the first few weeks, salvage from the cannabis farms that had been, in the months before the impact, a quietly booming agricultural industry in several regions. Those farms had been designed to grow plants without sunlight, in controlled indoor environments, using high-efficiency LED arrays calibrated to the specific light wavelengths that plants need to photosynthesize. When the people who survived near those farms made their way underground, some of them had the presence of mind to bring the equipment. It is the kind of absurdity that becomes, in retrospect, a turning point. Grow lights designed for a recreational drug, becoming the technological foundation of a species' food supply. Nobody who lived through the impact was on a low-carb diet. You ate what grew, and what grew was what you could convince to grow in a tunnel with salvaged lights and a substrate that you were deliberately not examining too closely. In London, the Circle Line became a farm. This is a sentence that would have sounded like a metaphor before April 13th, and after it became simply a description of the physical reality inside the London Underground. The Circle Line is a roughly circular route connecting major stations, with tunnels that run mostly at a shallow depth where there was room, after the trains stopped running, to remove sections of track and replace them with growing beds. The subway map that Londoners had carried in their pockets for generations, that iconic colour-coded diagram of a transit system, became, in the hands of the people living below the city, something closer to an agricultural grid. The Circle Line, wheat and mushrooms and greens. The Northern Line, storage and medical. The Jubilee, workshops and governance. The map did not change. What the map described had changed completely. Leadership emerged because it always does, in the way that humans in groups will always, eventually, organize themselves into some structure of decision-making, rather than continue in the exhausting anarchy of no structure at all. The councils that formed in the first months were not elegant. They were contested and imperfect and sometimes cruel. But they made decisions, and the decisions were recorded, and the records became something like law. People voted. In the tunnels under Moscow, under London, under a dozen other cities where enough people had survived, and enough structure remained to make a vote meaningful, people cast ballots and counted them, and abided by the results, because the alternative was worse than the process. And between the colonies, voices. Ham radio operators, people who had, before the impact, maintained this antique hobby of transmitting voices on shortwave frequencies. People who had been mildly teased for their attachment to a technology that predated the internet by decades, became, in the months after April 13th, the connective tissue of whatever civilization was still alive. The equipment was simple enough to repair and power with generators salvaged from the surface. And in the static threaded nights of the first winter, you could hear them. Tulsa checking in on Dallas, asking whether the colony there had water, whether the fungal crop had taken, whether anyone needed the seed stock that Tulsa had managed to preserve. Dallas answering. Both of them not knowing quite what they were, whether they were cities still, or outposts, or simply voices, but reaching for each other across the dark with the particular human insistence on not being alone. Trade routes followed the radio networks. What London had that Moscow needed, Moscow had something London could use, and the arrangements were made over frequency bands and honored in the dark. The tunnels held. The food barely held. The people, in numbers that would have seemed impossibly small, measured against any pre-impact accounting of what the world contained, held. And through all of it, through the disease and the digging and the grief and the elections, everyone was waiting for the same thing. They were waiting for the day when someone would climb a ladder to a hatch they had not opened in months, push it up against whatever weight of changed world sat on top of it, and step out into an atmosphere they could breathe. That day came. Not in the timeline the models had predicted, not in the 50 years that atmospheric scientists, working from the best data available in the first weeks after impact, had projected before the dust would thin enough to allow meaningful sunlight back to the surface. The models said 50 years. The dust settled in 18. The atmosphere, it turned out, had mechanisms for clearing itself that the pre-impact models had underweighted. Chemical processes in the stratosphere that broke down particulate matter faster than the simulations expected. And by the middle of the 18th year after April 13th, the sensors that the underground colonies had been running continuously on the surface showed light levels crossing the threshold that the agricultural committees had been waiting nearly 2 decades to see. 18 years is a long time to live underground. It is long enough for a child born in the first year of the tunnels to have grown into an adult who had never once stood in open air, never once felt rain on their face, never once seen the horizon as anything other than a wall. And 18 years is also, measured against the 50 that everyone had prepared for, something close to a miracle. The Svalbard Global Seed Vault had survived. It sits inside a mountain on an island in the Norwegian Arctic, roughly 800 miles from the North Pole, carved into permafrost that the impact had disturbed but not destroyed. And the seeds inside, more than 1 million varieties of food crops from nearly every agricultural tradition that humanity had ever developed, were intact. The people who had built that vault in 2008 had been thinking about nuclear war, about pandemics, about the slow creep of climate change making certain crops unviable in the regions where they had always grown, and what they had actually built, without quite knowing it, was the insurance policy against the thing nobody believed would actually happen. The vault had been stocked by countries that no longer existed. The seeds inside it were the last biological memory of agricultural systems that had been wiped from the surface of the earth. When the first teams climbed out of the Norwegian tunnels and made their way to Svalbard, what they found there was not just seeds. It was the instructions for a civilization that needed, slowly and painfully, to be rebuilt. 6 months after the first emergence, 6 months of topsoil testing, of atmospheric measurement, of cautious trial plantings in the fields nearest to the tunnel exits, in the places where the soil had retained enough structure to hold a root, the first wheat harvest came in. 8,000 tons. That number sounds like agriculture. It sounds like a figure from a quarterly report. The kind of statistic that a government bureau might publish in a document that nobody reads. But what that number actually represented, in the spring of the 18th year after impact, was something that no spreadsheet could quite contain. It was the first proof, tangible and edible and real, that the surface of the earth could feed a human being again. 8,000 tons sounds small measured against what the world had once produced. Before April 13th, global wheat production had exceeded 700 million tons per year. 8,000 tons is a fraction so thin it is barely worth calculating. But 8,000 tons meant that the soil was alive, that the sun was reaching the fields, that the cycle that had sustained every agricultural civilization in human history was turning again, and the people who ate that first bread, who had spent 18 years on mushrooms and hydroponic greens and whatever protein the tunnel farms could coax from the dark, did not care about the fraction. They cared about the bread. The first baby born above ground was named Dawn Mitchell. She was born in Boulder, Colorado, in an above-ground medical facility that the survivors there had constructed in the months following emergence, and she was named for the obvious reason, which is that her parents understood, with the particular clarity of people who had lived underground for 18 years, exactly what her birth meant. Dawn Mitchell grew up in a world that was quieter than any world that had ever existed in human memory. 80% of the animal species that had lived on Earth before April 13th were gone. Not diminished, not reduced to remnant populations in protected reserves. Gone. The specific texture of sound that had always accompanied human life on the surface. Birdsong in the morning, insects in the summer, the particular ambient noise of a living ecosystem doing its 10,000 simultaneous things, was absent in a way that survivors described, again and again in the written accounts they left behind, as the thing that disturbed them more than any other single fact of the New World. The silence was the grief that would not end. And then there was the memorial. The Catalina crater. Memorial stretches for 12 miles along what was once the coast of Southern California. 12 miles of black granite rising from the edge of the impact zone in a continuous wall that follows the curve of the crater's northern lip. 12 miles of stone is difficult to picture. It is roughly the distance from one end of Manhattan to the other. A stretch of ground that, in the old world, would have contained millions of people and thousands of buildings and the entire compressed complexity of a major city. The memorial is that long because the loss it records is that large. 4 billion names are cut into that granite, each name pressed into the stone in letters small enough that from any normal viewing distance, the wall appears not as text, but as texture. A surface that seems almost smooth until you step close enough to see that every millimeter of it is someone's name. A child, visiting the memorial for the first time, asked her mother where her grandfather's name was. The mother did not answer immediately because there was no immediate answer. There were 4 billion names on that wall. The International Apophis detection grid was built in the years following emergence. 10,000 satellites, distributed across orbital planes that provided continuous coverage of every approach vector into the inner solar system. Sensors capable of detecting objects as small as 30 feet across, at distances measured in millions of miles. The cost of building and maintaining that grid was approximately 1/3 of the total economic output of the surviving world. 1/3 of every material resource, every hour of labor, every engineered component that humanity could produce during the 2 decades it took to complete the network. And nobody complained about the cost. There were no budget debates, no competing priorities, no arguments about whether the money might be better spent on something more immediately pressing. The people who authorized the grid had lived through the impact, or had been born to parents who had, and the question of whether the cost was justified did not require an answer, because the answer was written across 12 miles of black granite on the California coast. And every one of the 4 billion names on that wall was an argument that no legislature needed to hear twice. The detection system that, before April 13th, would have cost a fraction of a single year's global military spending, a fraction so small it would have been a rounding error in the accounting of any major government, was built afterward at a cost that bent the entire surviving economy for a generation. Before the impact, the funding was never prioritized. After it, nobody asked whether it was worth it. Every year, on April 13th, the colonies observed what they called Sky Day. Not a holiday in any festive sense. A day of looking up. A day of staying above ground. Of standing in the open air that people had once moved through without noticing it. And being, for a few hours, simply present in it. The memorial committees would read names, not all 4 billion, which would take lifetimes, but a selection, chosen by lot, so that in any given year the names read aloud belonged to people from every place the impact had touched. And children who had grown up in the new world would stand next to people who remembered the old one. And between them, in the gap between what those children had never known and what the older ones could never stop knowing, was the entire weight of what had happened. That is where this story ends. 18 years in the dark, a child named Dawn, bred from seeds that had outlasted civilization, and 12 miles of names that the living carried forward for the dead, into a sky that finally was open again. But here is the thing that matters most, and it is the thing toward which every part of this story has been quietly moving. None of it was real. The tunnels, the wheat, Dawn Mitchell, the granite wall, the child asking about her grandfather, all of it was a way of making you feel, in your body, what the numbers have been trying to tell you for the last hour. Because there is an asteroid called Apophis, and it is real, and it is coming, and what happens next is not fiction. So here is what was real. Apophis is real. It was discovered on June 19th, 2004, at Kitt Peak Observatory in Arizona, and within months of its discovery, it carried the highest impact probability ever recorded for an object of its size, a 1 in 37 chance of striking Earth in 2029, a rating of 4 on the Torino scale, which had never been reached before and has not been reached since. The keyhole was real, a window in space approximately 2,000 feet across, through which Apophis would have needed to pass in 2029 to be redirected by Earth's gravity onto a collision course for 2036. The gravitational drift caused by absorbed sunlight, the Yarkovsky effect, was real, measurable, documented, and for a period genuinely concerning. All of that was real, and for several years the scientists tracking it were not performing caution. They were practicing it. But here is what we now know, and it matters. Apophis will miss the keyhole. The observations made possible by improved radar data and continued tracking have given astronomers enough information to say with confidence that when Apophis makes its closest approach on April 13th, 2029, it will pass through the neighborhood of our geostationary satellites, visible to the naked eye from parts of Europe, Africa, and Western Asia, tumbling slowly through a sky that will have no idea what almost happened, and it will miss. The 2036 impact scenario is off the table. Apophis is not going to destroy Los Angeles. The fictional collapse, the 90-day countdown, the woman at the window of her Brentwood home watching the sky pull back the ocean, none of that is going to happen on April 13th, 2036. But you need to sit with the distinction between Apophis specifically is not a threat and we are safe, because those are not the same sentence. The Younger Dryas impact is real. 12,800 years ago, something entered Earth's atmosphere above the North American ice sheet and released energy on a scale that modern civilization has never witnessed. A comet or fragmented body that left iridium, shocked quartz, nanodiamonds, and glass spherules across more than 40 sites on 4 continents, burned a black mat of destruction into the sediment record, and preceded the disappearance of 2/3 of the human population, then alive. That evidence exists. It has been replicated. The markers are in the ground. The event happened, and civilization reset, and the species recovered, and then kept living as though nothing in the sky could end it again. The 25,000 city killers are real. Roughly 11,500 of them have been tracked. The other 13,500 have not. They are in the dark right now, on orbital paths we have not measured, crossing regions of sky we have not studied, and any one of them, if it were to intersect Earth's path at the wrong moment, would release more energy than every nuclear weapon ever built by every nation in the history of the Cold War. Not a comparable amount of energy. More. One medium-sized asteroid, not a civilization ender, not something on the scale of a Chicxulub, not the kind of object that terminates geological eras. Just a city killer. The class of object we have been talking about for the last hour. The category with 13,500 untracked members releases more energy on impact than the entire nuclear arsenal of the 20th century combined. Every warhead the United States ever aimed at the Soviet Union, every warhead the Soviet Union ever aimed back, every test detonation, every weapon stockpiled in silos and submarines and bunkers across a planet that spent decades preparing to destroy itself. That is less than one rock. That is not a metaphor. That is a measurement. And there are 13,500 of them we cannot see. DART was real. On September 26th, 2022, a spacecraft the size of a vending machine traveling at 14,000 miles per hour struck a 500-foot asteroid called Dimorphos, and it worked. The orbital period changed by 33 minutes, 25 times the minimum threshold the mission required. The rubble pile structure of Dimorphos actually amplified the deflection, ejecting a plume of material that acted like a thruster, and the models were off by a factor of 25, not because the mission failed, but because reality was more cooperative than the engineers had dared to calculate. We know how to move an asteroid. We have done it. The technology exists, and it works. And the only thing standing between us and a functional planetary defense is the question of whether we will choose to build one before we need it, rather than after. The fictional reconstruction was not invented to frighten. Every physical detail of the impact sequence, the thermal pulse, the blast wave arriving at Mach 2, the crater 12 miles across, the tsunami climbing to 150 meters, the ejector reaching 7 states, was built from real impact physics, scaled to an object of Apophis' size and composition. The societal collapse was extrapolated from documented human behavior during previous civilizational disruptions. The fictional scenario was not a horror story constructed for emotional effect. It was an illustration of what the numbers actually mean when they stop being numbers and become events. And this is where we arrive at the only real fiction in everything you have heard. The idea that we are perfectly safe. That is the invention. That is the story with no supporting evidence. The detection gaps are real. The untracked objects are real. The history of civilization resetting impacts is written in the sediment of 4 continents, and the intervals between such events are not long enough for comfort when measured against the span of time a species can expect to survive if it pays attention. It is not a question of whether something like this will happen again. It is a question of when, and whether we will be watching when it does. We are the first species in 4.5 billion years of life on this planet that can see the threat coming and has the tools to stop it. Every species that lived through every previous extinction, every organism that vanished when something fell out of the sky, lacked both of those things. They could not see it. They could not have stopped it. They simply died. We have the telescopes, we have the spacecraft, we have the proof, demonstrated on a real asteroid in deep space, that deflection works. The question that remains is not technical. It is not financial. The fictional cost of 1/3 of a recovered civilization's economic output, spent for decades on post-impact detection, dwarfs by orders of magnitude what a real detection network would cost before an impact happens. The question is whether the people alive right now, in this window, before the next Apophis-class object threads the wrong piece of sky, will decide that the answer to "will we act?" is yes, while there is still time to make that decision matter. The big fiction is that we're perfectly safe. We are not. And the choice left is whether to be moved by the disaster that almost happened, or to remain unaware of the one that eventually will. And here is where the argument stops adding evidence and starts asking what the evidence means. Not what it means in the abstract, in the way that large numbers mean something when you read them on a page and then set the page down. What it means in the particular right now, with everything you have heard still sitting in the air between you and the ceiling. Because the thing about all of this, the detection gaps, the untracked objects, the sediment record on 4 continents, the keyhole 2,000 feet wide that Apophis will miss by a margin that took decades to measure with confidence, is that it does not resolve into comfort just because the numbers currently favor us. The numbers have always eventually stopped favoring something. There are 2 choices available to anyone who has spent time with this material. The first is to be motivated by the disaster that almost happened, by April 13th, 2029, which will arrive as an ordinary Friday to most people alive, while a rock the size of a skyscraper passes closer to the surface of this planet than the satellites carrying phone signals and weather data. That day exists. It is on the calendar, and whether it becomes a warning that shook a civilization into building the infrastructure it should have built 30 years earlier, or whether it becomes a footnote that most people missed while making dinner, depends entirely on what happens in the years between now and then. The second choice is to remain unaware of the one that eventually will come, and to let that unawareness function as a policy, as a budget decision, as a collective shrug dressed up as normalcy. There is no third option. The middle ground, the comfortable assumption that someone, somewhere, with the right credentials and sufficient funding, is already handling this, is precisely the fiction that the history in this video was assembled to dismantle. No one is fully handling it yet. The network is incomplete. The survey is unfinished. The political will to treat the sky as something worth watching systematically has not yet arrived, in the form of actual sustained commitment from the nations with the resources to provide it. And the cost of not deciding, expressed in the only unit that genuinely communicates scale, is the cost of reconstruction versus the cost of prevention. One is a fraction of a year's global defense spending, spent over decades, to build telescopes and develop spacecraft and maintain the tracking infrastructure that turns a potential extinction into a manageable engineering problem. The other is the economic output of whatever fraction of civilization survives, redirected entirely toward rebuilding for generations, from a hole 12 miles wide and a coastline that moved. The math does not require a calculator. It requires only the willingness to hold both numbers in the same thought at the same time and notice the difference between them. We are the first species in 4.5 billion years of life on this planet, with the capacity to do both things. See the threat before it arrives, and change its path before it arrives. Every creature that died in every previous impact, every organism that had no warning, no tool, and no framework for understanding what was falling toward it, lacked those two things entirely. We do not lack them. The window that separates us from every species that came before is not a technological window. The telescopes exist. The spacecraft exist. The proof that deflection works is sitting in the orbital mechanics of a small moon around a distant asteroid, its period permanently shortened by 33 minutes because a spacecraft the weight of a vending machine hit it at the right angle. The window is made of political will, and political will is made of exactly what you are made of. People who decide that something matters and act as though it does before the moment when acting no longer changes anything. In a few years, you will be able to go outside on an April night and find Apophis in the sky with a decent pair of binoculars. It will look like a point of light, unremarkable, the way everything in the sky looks unremarkable until you understand what it is. And when you see it, you will know something most of the people standing near you will not know, that it has been here before, that it will be here again, and that the version of April 13th that stays a close pass rather than becoming something else is not a guarantee written into the structure of the universe. It is a result. It is the accumulated result of people who looked up, who measured carefully, who built the tools to know the difference between safe and almost safe, and who made that distinction matter. The child at the memorial in the story asked why no one stopped it. That question is fictional. For now. The answer to whether it stays fictional is not in the sky. It is here.